Most students learn matrix vector multiplication one way, and it's the less useful way. The standard method computes each entry of the result separately using dot products row by row. It works, but it hides the deeper structure. There's a second method that reveals what matrix vector multiplication really means. By the end of this video, you'll see every matrix product differently, and it will change how you think about linear algebra. Let's start with a concrete example and compute it both ways. Take the matrix A with rows 2, 5, and 1, 3, so a 2 by 2 matrix, and the vector X with entries 1 and 2. Our goal is to compute the product A times X. We'll do it first, the familiar way, then the better way. The row method computes each entry of A times X by taking the dot product of a row of A with X. A dot product multiplies corresponding entries and then sums the results. Let's start with row 1 of A, which has the entries 2 and 5. We dot this with X, which is 1, 2. That gives 2 times 1 plus 5 times 2, which equals 2 plus 10, which equals 12. So 12 is the first entry of our result. Now take row 2 of A with entries 1 and 3. Dot this with X, 1 times 1 plus 3 times 2 equals 1 plus 6, which equals 7. That's the second entry. So A times X equals the vector 12, 7. This is how most textbooks teach matrix vector multiplication, row by row, entry by entry. Each output is computed in isolation. Now let's rewind and look at the exact same multiplication from a completely different angle. Instead of extracting rows, we extract the columns of A. Column 1 is the vector 2, 1. Column 2 is the vector 5, 3. The column method says a times X equals X, 1 times column 1, plus X 2 times column 2. This is what we call a linear combination. We scale each column vector by the corresponding entry of X and then add the scaled vectors together. Here X1 is 1 and X2 is 2. So we compute 1 times the vector 2, 1, that gives us 2, 1. Then 2 times the vector 5, 3, that gives us 10, 6. Now we add these two vectors together. 2 plus 10 is 12, and 1 plus 6 is 7. So the result is 12, 7. That's the same answer we got before, but from a completely different perspective, the column method. Here's the geometric picture. On a coordinate plane, column 1 is an arrow pointing to the point 2, 1. Column 2 is an arrow pointing to 5, 3. Now we scale column 1 by 1. It stays at 2, 1. We scale column 2 by 2. It stretches out to 10, 6. Next, we place these arrows head to tail, start at the origin and follow the first arrow to 2, 1. Then from that tip, add the second arrow of 10, 6. You arrive at the point 12, 7. The bold red arrow from the origin to 12, 7 is our result, a times X. The result is visibly built by combining the columns of A, weighted by the entries of X. This is the geometric essence of matrix vector multiplication. So both methods give 12, 7. The column method earns its preference by telling you more than just an answer. It tells you what kind of answer is possible. Every product A times X for any vector X is a linear combination of A's columns. Let's see this in action. If X equals 1, 0, we get just the first column, 2, 1. If X equals 0, 1, we get just the second column, 5, 3. If X equals 1, 1, we get 2 plus 5, 1 plus 3, which is 7, 4. If X equals negative 1, 2, we get negative 2 plus 10, negative 1 plus 6, which is 8, 5. If X equals 2, negative 1, we get 4 minus 5, 2 minus 3, which is negative 1, negative 1. And if X equals 3, 1, we get 6 plus 5, 3 plus 3, which is 11, 6, 9. Notice how these result vectors spread out across the plane. The set of all such linear combinations is called the column space of A. Now, since our two columns, 2, 1, and 5, 3, are independent vectors in R2, The column space fills the entire plane. Every vector in R2 is reachable as some linear combination of these columns. Here's a side-by-side comparison of the two methods. On the left, we have the row or dot product method. On the right, we have the column or linear combination method. First, let's compare what each method computes per step. The row method computes one entry of A times X per step, and the column method computes the entire vector A times X as a single sum. Next, consider the perspective each method offers. And the row method treats each output independently. The column method views the result as a combination of column vectors. Now, what does each method reveal? The row method reveals individual values. The column method reveals the column space, that is all reachable outputs of the matrix. Finally, when should you use each? The row method is best for quick hand calculations. The column method is best for conceptual understanding and proofs. Notice the emphasis on the column method. It gives us deeper insight into the structure of matrix multiplication. One important point, these two methods are not competing algorithms. They always produce identical results. The same arithmetic, just regrouped. The preference for the column view is about interpretation, not computation. Neither method is wrong. Now here's the payoff. When you see the equation Ax equals b, the column method reframes it completely. You're looking for weights x1 and x2 that combine A's columns to produce b. In other words, Ax equals b asks, is b a linear combination of the columns of A? This single reframe powers everything ahead in linear algebra. It connects to solving systems of equations, understanding when solutions exist, and grasping what a matrix does as a linear transformation. Every time you see Ax, think, which combination of the columns am I making? The idea will guide you through the entire course.